Dr. Hansen, thanks so much for joining us.
Sure.
So help us in a nutshell understand your findings.
What we show is that there is a connection to these extreme weather events that we've been seeing. The probability of these unusually hot spells, forest fires, and extreme droughts has increased substantially over the last few decades. We had shown I'd shown dice in the 1980s when I testified to Congress about global warming. And I said that the frequency of unusually warm seasons was going to increase. So I used one dice for typical or average climate that existed 50 years ago. There were equal chances of an average climate, which was represented by a white side of a dice, or an unusually warm season, which was red, or unusually cool season, which was blue. You had equal chances of those. But what we said was that by the end of the century, we would have loaded dice, so that only one side would be normal, one side cooler than normal, and four sides would be unusually warm. Now, in fact, that is what has happened. However, what I didn't think about at the time, in the 1980s, was that as we push the climate toward these hotter climates, these higher temperatures, the extremes, the highest temperatures, will be very extreme. And we're now getting about 10% of the area in a given summer is covered by what we call 3 standard deviation anomalies. Those would have occurred only once or twice out of 1,000 times 50 years ago. But now they're occurring about 10% of the time. That's the wildfires, the extreme droughts, the heat waves. Those are now a significant chance of having those, and those are the things that have big economic impacts.
So explain how we know that these events are happening and that they're not part of any sort of natural cycle.
They are, in fact, a product of global warming, and we can see that very easily. One thing, I think that the public can appreciate what we call the bell curve. You know, when you have a random variable, they tend to fall on both sides of the average value, sometimes colder than normal, sometimes hotter than normal. And this is the way this bell curve looked in the 1980s. But as time went on, as the planet gets warmer, it starts shifting toward the right, and you get more red and less blue. And by now, this past decade, it has shifted so far that we've got about 10% of the cases out here in this extreme warm anomaly, more than 3 standard deviations. And to understand, it averaged over the whole summer, it's only a few degrees warmer, a few degrees Celsius warmer. But that's a big effect. To see how important that is, look at Moscow 2 years ago, Texas last year, the Midwest this year.
So your research shows that the temperature increases between the last 30 years and the 30 years before that have increased by about a degree Fahrenheit. Now, is that within the sampling error? Is that significant?
Oh, it's significant. It's much larger than the error of measurement. And it's enough to change the frequency of these extreme events by a large amount. So it's important. In fact, it's now driven our climate outside the range that has existed the last 10,000 years, this geologic epoch that we call the Holocene.
So one of the scientists that we asked for comment on your paper said, hey, you know what, you're paying attention partly because it's Dr. Hansen. The science that the IPCC report in 2007 has said some of the same things he's saying now. Is there some new science? Is there some new findings that you're talking about today?
Yeah, absolutely. They did not show this sort of a shift in the probability distribution for the temperatures of a summer season. And this is extremely important because it's the large anomalies that have the practical impact. You can see what's happening in the Midwest this year.
All right, Dr. James Hansen, thanks so much for joining us.
Thanks.